where we left off last night on day 2/3 of explicit versus recursive formulas. So this is exactly where we left off. We were doing some examples. So let's go on to number 5 here. Again, let's see what we're doing. Part A, identify the definition as recursive or explicit. And again, how I told you guys to figure that out. Does it have one equation or does it have two equations? Well, this has two equations, so it's got to be recursive. And then we got to find the first three terms of the sequence. And again, recall, the good thing about recursive is that it always gives you the first term, which is nice. So we have the first term, j sub 1, which again, doesn't matter what letter we use. We could use A, we could use B, we can use J. J sub 1 equals 3. J sub 2, well, what do we do for recursive again? Remember that whatever this piece is right here, this j sub n plus 1, all that means is that it's your next term. All right, that's what we're trying to find next, aka j sub 2. And then whatever it equals, even though it might not say j sub n minus 1, it's different here because it says j sub n plus 1. Just understand that all this means, this piece here, let me get the highlighter, j sub n right here, all this is that it means the previous term. And that's the way it always works with recursive formulas. Okay, so we got to plug in the previous term. This whole thing is highlighted, and then we can figure out what term comes next. Okay. So if I plug in the previous term, well, I know the previous term is, in this case, 3. It's going to be 3, and the rule is to square it. So 3 squared becomes 9. And then the third term, j sub 3, well, I'm going to take the previous term and square it. So the third term is 81. So the first three terms of the sequence are 3, 9, and 81. Okay. And number 6, what kind of sequence do we have? Well, it's one equation, therefore it's explicit. All right, and we got to find the first three terms. So we have k sub 1, and all I'm doing is I'm substituting in for n. So anywhere I see an n, I'm going to substitute in 1. So it's going to be 12 minus 3 parentheses 1 minus 1. And if you have your calculator, you can type that in exactly as you see it. If not, we got to rely on our order of operations, which would be 12 minus 3 times 0. This just ends up being 0, so 12 minus 0 is just 12. All right, k sub 2, second term. Anywhere I see 2 for n, I'm going to plug in. So 12 minus 3 parentheses 2 minus 1. Again, order of operations, it'll be 12 minus 3 times 1, which is just 12 minus 3, which is 9. And k sub 3, that's going to be 12 minus 3 parentheses 3 minus 1. That's going to be 12 minus 3 times 2. And that's going to be 12 minus 6, which would be just 6. So the first three terms of this sequence are 12, 9, 6. All right. Let's move on to number 7. Write both a recursive, let's do recursive in, I don't know, let's do it in red. both a recursive and an explicit definition for the following sequence. All right. So we know that for explicit, just like we did before, it's going to follow dino, right? This is going to follow dino, and recursive, we're going to need to have two equations. So we're going to need two equations over here. That's a 2, and one equation over here. All right. And let's just be extra careful about what it is that these terms are. Right, this 4, that's your a sub 1. This 8 is your a sub 2. 12 is a sub 3. 16 is a sub 4. 20 is a sub 5. Now the next thing I want to figure out, is this a arithmetic or is this a geometric sequence? Well, let's look. 4 to 8, 8 to 12, 12 to 16, 16 to 20. Looks like we're adding 4 each time. Since we're adding 4 each time, that tells me it's going to be arithmetic. So we have a common difference of positive 4. So let's start with explicit, because that's the easy one, at least in my opinion. It's a little bit easier to deal with than recursive. So explicit is one equation. Start off with a sub n. And let's do the dino, right? Di stands for the difference between the terms, which is 4. Dino, the n in the middle. And then the O means 1 before the first term. Well, 1 before the first term would just be 0, right? So we don't even need to put plus 0. Here we have our explicit definition. And now let's do recursive. Again, the good thing about recursive is that we can easily give the first part of the first equation. Always two equations. The first part is always the first term. A sub 1 is 4. And then the second part, a sub n, which is the next term, we always need to include the previous term, aka a sub n minus 1, right? The previous term. In this case, the previous term before the first term was 0. So then how would I get to the next term? Well, I'm just adding 4 to it, right? If I was to look at a sub 2, let me just show you an example here using the recursive that we just made. I have a sub 1 equals 4. If I want to find a sub 2, I'm taking the previous term, which before the first term was 0, and I'm adding 4. Okay? So that's how that works. Okay, guys. Let's go on to the back page. Number 8, given the sequence 2, 4, 8, 16, list the next 3 terms of the sequence. Okay, that's easy. First, let's figure out, am I working with an arithmetic or am I working with a geometric? Well, what's the pattern? 2 to 4, 4 to 8, 8 to 16. It looks like we're multiplying by 2 each time. Right? So this is a geometric sequence. Now let's list the next 3 terms of the sequence. 2, 4, 8, 16. Well, 16 times 2 is 32. 32 times 2 is 64. 64 times 2, 128. Easy. Part B, what type of sequence is this? Oh, well, I guess we already have it. That's the first thing I like to determine. What kind of sequence are we working with? Well, we said it's geometric. Why is it geometric? Well, because the pattern is multiplying. Right? Pattern is multiplying. And let's even make sure that we put the common ratio with a common ratio of 2. Part C, write an explicit formula for A sub n. Well, again, guys, recall that geometric sequences, they mimic exponential functions. Okay? They look just like exponential functions, and we should know that an exponential function looks like y equals ab to the x. And the one difference, as we learned in class, I think yesterday, is that if I want to make it a sequence, it's going to follow this. It's going to look like a sub n equals a times r, a times r to the n minus 1. Right? We did that in our notebooks yesterday. A sub n equals a times r to the n minus 1. Sorry for that. So, a is my first term. R is my common ratio. And then the n is just a term that we're looking for. So, the explicit formula would look like a sub n equals a, 2 is my first term. My common ratio we said was 2 raised to the n minus 1. Okay. Now we have to write a recursive definition for the sequence. Well, okay, recursive means we have to have 2 equations. The first one is the easy one. It's a sub 1 is equal to 2, right? That's our first term is 2. And then we're going to have a sub n is equal to, this is where the previous term comes in, a sub n minus 1 times 2. Right, we would take the previous term, multiply it by 2. So for example, if I wanted to find a sub 2, I would take the previous term, which in this case was 2, and I would multiply it by 2, and I would get 4 as my second term, which matches up, because here's my second term of 4. Okay? Alright, number 9. Erin is memorizing words for a vocab test. She currently knows 25 words. She currently knows 25 words. Okay. Each day for the next 6 days, she increased the words memorized by 3. Okay, so a few keywords here. Increased and by 3. So every day she's increasing by 3. 3 words per day. Part A. Write the sequence for the number of words that Erin memorized for each of the 7 days. What type of sequence does this create? Okay, well, it's not saying give me a formula, it's just saying write the sequence. So if she currently knows 25 days on day 1, that's the first term. That's your a sub 1, first term of the sequence. And it's saying that she's increasing the words memorized by 3 each day. So each day that goes by, we're increasing by 3, right? So if we start at 25, a sub 1, and we go on to the next day, we're increasing by 3, so it's going to be 28, right? That's your a sub 2. And then the next day would be 31. That's your a sub 3. Next day would be 34. Here's your 4th term. Next day would be 37. That's your 5th term. Next day would be 40. That's your 6th term. And then the seventh and final day, she should know 43 words, which is the seventh term in the sequence. And since we're increasing by adding 3 each day, it's an arithmetic sequence. Okay. Part B, write a recursive formula for this sequence. Okay, recursive means 2 equations. The first equation is the first term. So a sub 1 equals 25. And then the second equation always includes the previous term. So a sub n is equal to a sub n minus 1. And then I'm going to add the common difference of plus 3. Okay? And again, all this is your previous term. And just to be safe, if I wanted to find the second term, now if I use my recursive sequence or formula, a sub 2 means I'm going to take my previous term, which was 25, that's what it says to do, and add 3 to it, so I would get 28 as my second term, which matches up to what we got up here. All right, and guys, that is the end of this